Hello everyone. Once again welcome to my video lecture series of Advanced Calculus and Numerical Methods with subject code 18MAT21. Here in this lecture 3 of module 1 vector calculus, I will take vector identities and problems of vector calculus using these vector identities. Before taking vector identities, let me recall all the vector operations: gradient, divergence and curl. So where the gradient on a scalar point function f is given by del f is equal to, as del you know, it is the operator I dou by dou x plus j dou by dou y plus k dou by dou z. So del f is dou f by dou xi plus dou f by dou yj plus dou f by dou zk. Similarly, divergence f, that is dot product between del operator and the vector point function f. So del dot f is nothing but dou f1 by dou x plus dou f2 by dou y plus dou f3 by dou z. Similarly, curl f means cross product between the vector operator del and the vector point function f, del cross f. So which is nothing but determinant ijk dou by dou x dou by dou y dou by dou z and f1 f2 f3. So all know these concepts very well, correct? Now students, when we move on to the vector identities or the theorems, so while proving, instead of taking the definition like this way, we use the summation notation. So del f, as all of you know, this is dou f by dou xi plus dou f by dou yj plus dou f by dou zk, which in turn I can write by using summation I dou f by dou x. So that means summation I dou f by dou x means I can extend it to the remaining terms just by replacing in cyclic order x, y, z in cyclic order, I, j, k in cyclic order. That is I dou f by dou x plus j dou f by dou y plus k dou f by dou z. I'll get back this. Similar way, del dot f, as of now we know that it is dou f1 by dou x plus dou f2 by dou y plus dou f3 by dou z. So which I can write by using summation, that is summation I dou by dou x dot f. So it is easy to remember, del dot f. So operator del is nothing but I dou by dou x plus j dou by dou y plus k dou by dou z, which in using notation summation I can write summation I dou by dou x dot the vector f. So del dot f, here onwards while proving the identities I use this summation I dou by dou x dot f. Similarly, curl f, we can use summation notation, that is summation I dou by dou x cross f, correct? So del cross f, summation I dou by dou x cross f. Now apart from that, so we have this result, that is grade on a function of r, where r is nothing but magnitude of the vector r. The vector r is xi plus yj plus zk, and the magnitude is square root of x square plus y square plus z square, that is nothing but r. Suppose if I have the grade of a function of r, which I can get immediately by using this result, f dash of r by r into vector r, correct? Now we can take the vector identities. We'll take the identities or theorems one by one. The first one, prove that curl of grade phi equal to 0. Now what we have to take here is take grade of a scalar point function grade phi, that is dou phi by dou xi plus dou phi by dou yj plus dou phi by dou zk, then take curl on it, that is del cross del phi, and answer should be 0. So take LHS, that is del cross del phi, where del is the operator I dou by dou x plus j dou by dou y plus k dou by dou z operating on a scalar, that is gradient. So that is nothing but dou phi by dou xi plus dou phi by dou yj plus dou phi by dou zk. Now del cross of vector, this is a vector quantity, so we know that del cross f, so it is obtained, cross product is nothing but determinant of ijk, the second and third rows are the component of del and vector f. So here we have determinant of ijk dou by dou x, dou by dou y, dou by dou z, component of del, and the third row component of this vector, that is dou phi by dou x, dou phi by dou y, dou phi by dou z. So determinant expand along the first row, I plus minus plus, so plus I into dou by dou y of dou phi by dou z, second order partial derivative, that is dou square phi by dou y dou z, minus dou by dou z of dou phi by dou y, that is dou square phi by dou z dou y, minus j into dou by dou x of dou phi by dou z, dou square phi by dou x dou z, minus dou y dou z of dou phi by dou x, that is dou square phi by dou z dou x. Now component of k, that is dou by dou x of dou phi by dou y, dou square phi by dou x dou y, minus dou square phi by dou y dou x. Now, so what about the components here? The component of I having a mixed derivatives of second order. So here dou square phi by dou y dou z, we know that it is equal to dou square phi by dou z dou y. So that means it gets cancelled. The component of I is 0. Similar way, dou square phi by dou x dou z is same as dou square phi by dou z dou x. So component of j becomes 0, and as we have here also the components of k is also 0 because it is one and the same. Dou square phi by dou x dou y is equal to dou square phi by dou y dou x. We can get cancelled. It is nothing but 0 I plus 0 j plus 0 k, a 0 vector. So I have the curl of grade phi is 0 vector, correct? So I can now have curl of other two operator. So one is a div, but as all of you know that div is a scalar, curl is always on a vector, so curl of div is not possible. So we cannot expect now curl of div, correct? So curl of div f, vector f, cannot exist. Now what we can expect, one more is curl on curl. So this can be evaluated for any given vector field f. So if I ask what is curl of curl f, so we have to operate del, the cross product, twice, that is del cross f. So first evaluate this del cross f, obtain a resultant vector whatever we get, so take del cross on it again, so that gives curl of curl f. So one identity, now we have the 0 identities, curl of grade phi equal to 0, and next we can evaluate even curl of curl f by operating the cross product del on f twice. The second one, prove that div of curl f equal to 0. The first identity which we have taken on curl, that is curl of grade phi equal to 0. Here it is on div of curl f equal to 0. So we have to first get the curl on vector f, that is del cross f, which is a vector field, vector quantity. So one we can take div on it, that is del dot of del cross f, we need to prove equal to 0. So del dot of del cross f. So first expand this del cross f, that is del dot of determinant ijk dou by dou x dou by dou y dou by dou z, and the component of vector f is f1 f2 f3. As we know, vector f is f1i plus f2j plus f3k, where f1 f2 f3 are functions of x y z. So first take the curl of f. Once we get that, then we can take divergence on this vector. So plus I into dou by dou y of f3, dou f3 by dou y, minus dou f2 by dou z, minus j into dou f3 by dou x minus dou f1 by dou z, plus the component of k is dou f2 by dou x minus dou f1 by dou y. So we got curl f. Now take del dot of this vector. So as all of you know, del dot f, the dot product between del and the vector f, vector quantity f, is nothing but sum of the product of corresponding component dou f1 by dou x plus dou f2 by dou y plus dou f3 by dou z. Similar way here also we can get dou by dou x into dou f3 by dou y minus dou f2 by dou z, plus dou by dou y into the component of j here is minus of dou f3 by dou x minus dou f1 by dou z. That's why it is plus into minus, minus dou by dou y of dou f3 by dou x minus dou f1 by dou z, plus dou by dou z into dou f2 by dou x minus dou f1 by dou y. So now we can expand this. It is a second order partial derivative. Will get dou square f3 by dou x dou y minus dou square f2 by dou x dou z minus dou square f3 by dou y dou x minus of minus plus dou square f1 by dou y dou z plus dou square f2 by dou z dou x plus into minus minus dou square f1 by dou z dou y. We have just expanded it. Now if you observe this, so the like term dou square f3 by dou x dou y and dou square f3 by dou y dou x, which are same, so we have here plus sign and here minus, so we can cancel that. So dou square f3 by dou x dou y minus dou square f3 by dou y dou x gets cancelled. Similarly dou square f2 by dou x dou z minus, and here it is plus sign dou square f2 by dou z dou x. And third pair dou square f1 by dou y dou z with plus sign, dou square f1 by dou z dou y with minus sign also get cancelled. So totally it gives answer 0. So that means div of curl f is also 0. Now as we have seen on curl of grade phi is 0, but curl of curl f we can evaluate. Curl of div f is not possible, we cannot have it. Similarly div of curl f is 0. Now div of div, can it be possible? Div of div is not possible because div is a scalar, div is always on vector, so div of div a vector quantity is not possible. So what we can have is, now left out is div of grade, so we can have this div of grade phi, that is nothing but grade phi is del phi, div means del dot, so that is del dot del phi. So we'll take this del dot del phi as one more identity. We are going to take this as an identity. We'll prove that what is del dot del phi. So now two zeros identities we have. One is on curl, that is curl of grade phi equal to 0. Another is on div, that is div of curl f equal to 0. But one thing we can notice, that is here div of curl f, this 0, and curl of grade phi, that is also 0, but they are not similar. So why? Curl of grade, curl is always a vector quantity, so obviously this 0 is nothing but 0 vector, 0i plus 0j plus 0k, and div gives always a scalar, so this 0 is just a scalar. Div of curl f is a scalar quantity, that is 0 is a scalar, but curl of grade phi equal to 0 means it is a vector quantity, it is 0 vector. So we move on to the next identity, students. Third identity, prove that div of phi f is equal to grade phi dot f plus phi times div f. So here we take div or divergent of a scalar multiple of vector quantity, that is product of scalar and vector. So phi is a scalar function and f is a vector point function. So similarly we have one more identity. The next will be the curl of scalar multiple of vector point function f. Now how we can remember this? So for that we just make use of the basic property which we know. If suppose a and b are two vectors and phi is a scalar, then a dot phi b, so this phi a scalar we can shift anywhere you want. So that means a dot phi b is equal to vector a into phi dot b, or that is also equal to, you can take phi totally out of that bracket, that is phi times a dot b. So this is the one of the property which we have taken under vector algebra. So that is a dot phi b is equal to a phi dot b or phi times a dot b. We know that. Similarly, if you have here instead of dot we have cross, a cross phi b is equal to, so phi is a scalar, a and b are a vector as we have taken already. So a phi cross b, or that is same as phi times a cross b. So this I can use here also, as we know that phi is a scalar and f is a vector quantity. So if I take this in terms of notation, what we have, del dot phi f. So to remember this result, it is very simple, just we switch this phi, so I can shift this. So the one term is I can take phi to here, del phi dot f. So what is del phi means? I get one term is del phi dot f. So is it not del phi is a gradient of phi? So it is grade phi dot f. So the dot product between gradient of phi and the vector f, plus the second term is just if you take phi out of that, so that is phi times del dot f. So phi times del dot f. So what is del dot f means? The dot product between the vector operator del and the vector point function f is nothing but divergence of f. So that means it is phi times div f. So one can remember this easily. So now we can go for proving this identity, that is di on a scalar multiple of f is nothing but grade phi dot f plus phi times div f. So we'll take div of phi f, del dot phi f. Now I make use of the summation notation here. As you know, div of f, we know that div of f is dou f1 by dou x plus dou f2 by dou y plus dou f3 by dou z. But if we apply the summation notation, that is summation I dou by dou x dot f. Correct? Just now we have taken that too. So summation I dou by dou x dot f. So here I can write it as summation I dou by dou x dot phi f. Your phi f is totally a vector quantity, scalar multiple of vector. Totally it is a vector. So now I can use this result, what we have just taken, a dot phi b is equal to a phi dot b, or phi times a dot b. So here also I can just take this dou by dou x is a scalar, so I can switch here, I can shift it to here, that is I dot, I take it as summation I dot dou by dou x of phi f. So summation I dot dou by dou x of phi f means you have to differentiate phi f partially with respect to x using product rule. So derivative of first function into second plus first function into derivative of second. So I have summation I dot dou phi by dou x into f plus phi times dou f by dou x. Now we have two terms, we can split this summation. So we'll have a two summation. One is summation I dot dou phi by dou x f plus summation I dot phi dou f by dou x. This dou phi by dou x in the first summation is a scalar, so I can shift here, that is summation I dot dou phi by dou x f, I take it as summation I dou phi by dou x dot f. Correct? Now what is summation I dou phi by dou x? That is nothing but gradient of phi. If you expand this, you will get dou phi by dou xi plus dou phi by dou y j plus dou phi by dou zk, which is nothing but gradient of scalar function phi. So this is gradient of phi. So which is nothing but the first term what we expect we got, gradient phi dot f. Similarly, now the second summation, summation I dot phi dou f by dou x, where phi is a scalar, so I can shift anywhere I want. So I have taken totally out of that, that is phi times summation I dot dou f by dou x. Now summation I dot dou f by dou x, I can write it as summation I dou by dou x dot f. Again I can take that dou by dou x, now shift it, that I can write summation I dou by dou x dot f. So what is summation I dou by dou x dot f? That means it is divergence of f. So I got the first term as expected, grade phi dot f, and the second term I have phi times divergence of f. So that gives the result, students. So div of phi f, if I simplify by using the summation notation and go for differentiating partially with respect to x using the product rule and split the summation once again and switch that or shift that scalar as we require, so we'll get the required result, grade phi dot f plus phi times div f. Okay, so now this results we can use whenever we are finding divergence of a scalar multiple of vector. If you have a scalar into a vector, we can obviously use this result so that we can get the answer immediately. Now let us take the fourth identity. Prove that curl of a scalar multiple of vector, that is curl of phi into f, is equal to grade phi cross f plus phi times curl f. And the proof of this identity follows the same line of the third identity. So the thing is, I have to now take del cross, curl means cross product between del and the vector quantity. Here vector quantity is phi f, so del cross phi f, so which I can now get as grade phi cross f. As you know, we can shift phi here, that gives del phi, which is nothing but grade phi cross f, plus the second term is phi, we can take out of that del cross f. So phi times del cross f means nothing but curl f. So I can go for proving this identity in the similar way. So take LHS, that is curl of phi f del cross phi f. Del cross phi f, according to the summation notation, I can write summation I dou by dou x, that is del cross the vector phi f as it is I have written. So the del cross phi f is summation I dou by dou x cross phi f. Now I can take dou by dou x to here, that is summation I cross dou by dou x of phi f, which is nothing but by differentiating partially with respect to x using product rule, I get dou phi by dou x into f plus phi into derivative of second function, that is dou f by dou x. Now split this summation. Now this gives now two summation. One is summation I cross dou phi by dou x into f, which I write dou phi by dou x by taking here, that is summation I dou phi by dou x cross f. So which gives the first term of the proof, that is grade phi cross f, cross product between grade phi and the vector point function f, plus the second summation which I have here is summation I cross phi times dou f by dou x, where phi I have taken totally out, that is phi times summation I cross dou f by dou x, or which in turn I can say it is summation I dou by dou x cross f. Summation I dou by dou x cross f means del cross f, which is nothing but curl f. So I have finally the result which we require is grade phi cross f plus phi times curl f. So the divergence of phi f is grade phi dot f plus phi times divergence f, and curl of phi f is grade phi cross f plus phi times curl f. Fifth identity, div of grade f equal to, that is nothing but del dot del f, that is del square f, which is nothing but fxx means dou square f by dou x square plus dou square f by dou y square plus dou square f by dou z square. So we have already taken identity on div, that is div of curl f equal to 0. Correct? Div of curl f equal to 0. Now we have div of grade f, that is nothing but del square f, where del square is a Laplacian operator, which is nothing but dou square by dou x square plus dou square by dou y square plus dou square by dou z square. So del square, the operator is del square by dou x square plus dou square by dou y square plus dou square by dou z square, or I can write it as summation dou square by dou x square. Operating on f means partially differentiate f with respect to x, y, z twice. Sum of the partial derivative of f with respect to x, y, z twice. Symbolically I can write it as fxx plus fyy plus fzz. So I can prove this just by taking div of grade f means del dot del f. So what is del f? Now it is nothing but dou f by dou xi plus dou f by dou yj plus dou f by dou zk, the gradient of scalar function f. Now operate del on that, del dot. So that is nothing but now the sum of the product of components. The component of dou del is dou by dou xi plus dou by dou yj plus dou by dou zk. So take that dou by dou x of dou f by dou x, dou square f by dou x square, plus dou by dou y of dou f by dou y, dou square f by dou y square, plus dou by dou z of dou f by dou z, dou square f by dou z square. So we into this result now, symbolically I can write fxx plus fyy plus fzz. So divergence of grade f is nothing but del square f, or that is fxx plus fyy plus fzz. So whenever we have a problem on this div of grade f, so we can simply partially differentiate f with respect to x, y, z twice and sum it at that answer. So we'll get the divergence of grade f or del square f. So the next identity, prove that div of grade of f of r is equal to f double dash of r plus 2 by r times f dash of r. The identity on div of grade of f is nothing but del dot del f, which we have taken, that is a del square f, dou square f by dou x square plus dou square f by dou y square plus dou square f by dou z square. If your f is specifically a function of r, where r is magnitude of the vector r xi plus yj plus zk, then I can use this result immediately, as we have taken already the gradient of f of r. So that result is now known to us, which is nothing but f dash of r. Just differentiate f of r and then substitute here f dash of r by r into vector r. So that is for gradient of f of r. Similarly here it is div of grade of f of r. We can use this result. So that is nothing but f double dash of r plus 2 by r times f dash of r. So we can take left hand side, div of grade of f of r is nothing but del dot del of f of r, that is del square of f of r. So del square means Laplacian operator dou square by dou x square plus dou square by dou y square plus dou square by dou z square operating on f of r. So we have to differentiate f of r partially with respect to x, y, z twice. But as we know, f of r is a symmetric because r is magnitude of vector r, that is r is equal to square root of x square plus y square plus z square. So this is a symmetric function. So instead of operating dou square by dou x square, dou square by dou y square, dou square by dou z square, I take the summation notation. So I'll expand first dou square by dou x square of f of r, then I can extend it further for the remaining two terms. So what is dou square by dou x square of f of r? So we have to partially differentiate f of r with respect to x twice. So that is dou by dou x of f of r. So summation dou by dou x of f of r means f dash of r, derivative of f of r is f dash of r into inner term r, dou r by dou x. So what is dou r by dou x? Since we know r is square root of x square plus y square plus z square, differentiate partially with respect to x, dou r by dou x, treating y and z constant, that gives 1 by derivative of root x square plus y square plus z square is 1 by 2 root x square plus y square plus z square into inner term derivative with respect to x is 2x. So 2 gets cancelled. It is x by root x square plus y square plus z square, which is nothing but r. So which gives x by r. So dou r by dou x is x by r. So I have substituted that. So derivative of f of r partially with respect to x is f dash of r into x by r, or I have f dash of r by r into x. Now this you have to again differentiate partially with respect to x using product rule. So I can split this into three terms. One is f dash of r, another is 1 by r, and the last one is x. So differentiate by using product rule, derivative of first function second into third plus first into derivative of second into third plus first and second into derivative of third. So you can take that derivative of f dash of r is f double dash of r into inner term dou r by dou x, which is nothing but x by r. So x by r into x by r already we have, that gives x square by r square, plus first function as it is f dash of r into derivative of 1 by r is minus 1 by r square into derivative of r is dou r by dou x. So I have second term is f dash of r, differentiate only the middle term, the second term, that is minus 1 by r square into inner term r, dou r by dou x, which is nothing but x by r, into third term x as it is. So that means the second term we have minus f dash of r by r square into r, that is r cube, x into x square. So I have here f dash of r by r cube together into x square plus the third term, differentiate only the third term, leaving first and second as it is. F dash of r into 1 by r into derivative of x with respect to x is nothing but 1. So that's why we have the third term is f dash of r by r. So now this is the partial derivative of f of r with respect to x twice. Now I have to do that work for the remaining 2, dou square by dou y square of f of r plus dou square by dou z square of f of r, which I can do by replacing x, y, z into cyclic order. So what we have now, for dou square by dou y square of f of r, we'll have 3 terms once again. The first term will be f double dash of r y square by r square. The second term is minus f dash of r by r cube into y square. Third term is plus f dash of r by r. Similar, it happens for dou square by dou z square of f of r. So that means f dash of r by r repeatedly appear 3 times. So which I can write 3 times f dash of r by r. Now what about this here? For second term first term corresponding to first term, f double dash of r by r square into x square plus y square plus z square, because it comes for the remaining 2 terms as f double dash of r by r square y square, f double dash of r by r square z square. I have taken that together. So I have f double dash of r by r square into x square plus y square plus z square minus f dash of r by r cube into x square minus f dash of r by r cube into y square minus f dash of r by r cube into z square. So I can write f dash of r by r cube into x square plus y square plus z square. Now this third term repeats thrice, so I can write 3 times f dash of r by r. Now all of you know now r is equal to square root of x square plus y square plus z square, magnitude of vector r. So r square is x square plus y square plus z square. So this now we can replace as r square, which simplifies r square by r square gets cancelled, we'll get f double dash of r. And here also this is r square, which cancels with denominator r cube, leaves r, f dash of r by r with minus sign. So minus f dash of r by r plus 3 times f dash of r by r. So 3 minus 1. So 2 times f dash of r by r. So that is the expected answer here. Divergence of grade of f of r is equal to f double dash of r plus 2 by r times f dash of r. So student, whenever we have to find divergence of grade of a function of r, say it is r square or 1 by r square, so you can just differentiate twice, get f dash of r and f double dash of r, use this result, one can get the answer. Now after taking the proof of all these identities, we'll move on to the problems on it. The first problem, find del square f at 1, 1, 0 if f equal to 3x square z minus y square z cube plus 4x cube y plus 2x minus 3y minus 5. So del square f means we have to operate del square on f, where del square is a Laplacian operator, dou square by dou x square plus dou square by dou y square plus dou square by dou z square. So differentiate f partially with respect to x twice. Similarly, dou square f by dou y square and dou square f by dou z square. So partial derivatives we have to take. A first order partial derivative fx, dou f by dou x, that is 6xz independent of x, so it is 0 plus 12x square y plus 2. So we have dou f by dou x is 6xz plus 12x square y plus 2. Now if I differentiate this with respect to x again, that gives dou square f by dou x square, or symbolically I can write fxx, that is 6z plus 24xy. Now differentiate f partially with respect to y, it means treating x and z constant, which gives dou f by dou y or fy is equal to minus 2yz cube plus 4x cube plus 0 minus 3. So we have minus 2yz cube plus 4x cube minus 3. Again differentiate this partially with respect to y, that gives dou square f by dou y square. Second order partial derivatives fyy, which is nothing but minus 2z cube. So these are constants, so I have just minus 2z cube. Now differentiate partially with respect to z, treating x and y constant. So f suffix z, dou f by dou z. So that is 3x square minus 3y square z square plus 0, 0, 0, 0. So I have dou f by dou z, or f suffix z, is 3x square minus 3y square z square. Now differentiate partially with respect to z again. a second order partial derivative dou square f by dou z square, that is f suffix zz, is equal to 6 minus 6y square z. So we have all three partial derivatives of second order we got. So dou square f means fxx plus fyy plus fzz. But since it is at 1 comma 1 comma 0, so let me substitute the values of x y z as 1 comma 1 comma 0. So which we get fxx equal to, after substituting x equal to 1, y equal to 1, z equal to 0, that is 0 plus 24 into 1 into 1, that is 24. Fyy at z equal to 0, that is 0. Fzz at z equal to 0, again it is 0. So I have dou square f is fxx plus fyy plus fzz, which is nothing but 24. Second problem, show that del square of r power n is equal to n into n plus 1 r power n minus 2. So here del square is on a function of r. So I can use the result del square of f of r is equal to f double dash of r plus 2 by r times f dash of r. So that means we have to differentiate f of r, that is r power n, twice. Get f dash of r and f double dash of r, substitute in the formulae. So f of r is r power n, then differentiate once with respect to r, f dash of r, n r power n minus 1. Again if you differentiate, f double dash of r is n into r power n minus 1, derivative is n minus 1 into r power n minus 2. So we have the result, since del square of f of r is equal to f double dash of r plus 2 by r times f dash of r. So del square of r power n now becomes f double dash of r, n into n minus 1 r power n minus 2 plus 2 by r times f dash of r is n into r power n minus 1. So n into r power n minus 1 by r gives r power n minus 2. So r power n minus 2 is common. So we can take n into n minus 1 plus 2n times r power n minus 2. If you simplify this, that gives n square minus n plus 2n. Minus n plus 2n is plus n. N square plus n, or n into n plus 1. So the answer is n into n plus 1 r power n minus 2. So we got the result, del square of r power n is n into n plus 1 r power n minus 2. Now here if I say for what value of n this becomes 0, del square of r power n is 0. So for what value of n the result del square of r power n is 0. So that means I have to equate this to 0. So n into n plus 1 r power n minus 2 equal to 0 means it is n plus 1 equal to 0, means n equal to minus 1. If I substitute n equal to minus 1, that means del square of r power minus 1, that is nothing but 1 by r. So del square of 1 by r is 0. So if I want del square of 1 by r, definitely I'll get the answer as 0. So that's why we can write del square of 1 by r as 0. So third problem, it is gradient of r power n. So I have to prove that n r power n minus 2 into vector r, and vector r is xi plus yj plus zk. So the previous problem we got del square of r power n. So now it is del of r power n. So gradient of r power n, I can use the result, since again it is a function of r, del of f of r result I can use, which is nothing but f dash of r by r into vector r. So identify, by using this result I can prove that. So identify f of r, that is r power n, differentiate once, f dash of r is n r power n minus 1. So substitute directly here, that gives the result, del of r power n, gradient of r power n, therefore it is n r power n minus 1 divided by r into vector r, where n r power n minus 1 by r becomes r power n minus 2. So the required result what we have here is del of r power n we got, that is n r power n minus 2 into vector r. Fourth problem, if a del of unknown scalar function u is known to us, that is 2 times r power 4 into vector r, then find u. So it is a slightly different of what we usually have, that is gradient of scalar function we find. Now the answer is already known to us and we need to identify that scalar function. So it is, now the answer is 2 times r power 4 into vector r. So I use the result of gradient of r power n, that is known to us n r power n minus 2 into vector r, or we can find that by using the result del of f of r is f dash of r by r into vector r. So I'll get this result. Now see, it resembles the given answer, so I can write it as r power n minus 2 into vector r is nothing but del of r power n by n. Now I want r power 4 into vector r, means this index, the power should be 4. For what value of n this becomes 4? So that means 6 minus 2 is 4. So that means n should be 6. Substitute. So n equal to 6 means if I substitute n equal to 6, I'll get r power 4 into vector r, that is nothing but del of r power 6 by 6. So multiply both side by 2 so that I'll get the expected answer. So that is 2 times r power 4 into vector r is equal to del of r power 6 into 2 by 6. 2 by 6 is 3. So which is a constant I can take inside that. So that is gradient of r power 6 by 3. So your function, a scalar function u, must be r power 6 by 3, and you can take the constant c. So u is equal to r power 6 by 3 plus c is the required answer. Fifth question, we need to find curl and dive of a known vector r, that is xi plus yj plus zk. So as all of you know, curl r means del cross r. So get that cross product between del and the vector r, that is determinant ijk dou by dou x dou by dou y dou by dou z, and component of r is x y z. So I can get that I into dou by dou y of z, partially differentiate z with respect to y, means it is constant, so obviously 0, minus dou by dou z of y, again 0, so it is component of I is 0, minus j into dou by dou x of z, so partially differentiating z with respect to x means 0, minus dou by dou z of x, so that is also 0, so the component of j is 0, plus k into dou by dou x of y, 0, minus dou by dou y of x, again 0, so I have 0 I plus 0 j plus 0 k, that means curl of r is 0. And what about div of r? Del dot r. So as I know, del dot f means dou f1 by dou x plus dou f2 by dou y plus dou f3 by dou z. So here it is dou by dou x of x. The components are x, y, z. Dou x by dou x plus dou y by dou y plus dou z by dou z. So we'll get the partial derivative of x with respect to x is 1. Likewise 1, 1. 1 plus 1 plus 1, 3. So students, whenever we want to use this, that is we need to get the divergence and curl of vector r xi plus yj plus zk. So you can remember this result, div of r is 3 and curl of r is 0. So apart from that, if suppose while proving or getting the answer of some problems, if I need r dot r, where r is the position vector, that is xi plus yj plus zk, r dot r, so what it gives now? Sum of the products of component. So xi plus yj plus zk is the vector now, so that gives x into x plus y into y plus z into z, x square plus y square plus z square, so which is nothing but r square, because r is the magnitude of this vector, square root of x square plus y square plus z square. So I can remember now, whenever I want r dot r is r square. And what about r cross r? R cross r, the cross product between r itself is 0. So obviously we'll get 0, because if I write determinant ijk, the component of r is xyz, again the component is xyz. So I into x into, sorry, here y into z, yz minus zy, that is nothing but 0, yz minus yz, 0. The component of I is 0. Similarly, we will get component of j and k is 0, that is 0i plus 0j plus 0k. So I can take this as a note. Divergence of r is 3, curl of r is 0, and r dot r, that is r square, r cross r is 0. So the problem number 6, if r is xi plus yj plus zk, show that the gradient of 1 by r square is minus 2 by r power 4 into vector r, divergence of r vector r by r square, that is 1 by r square, divergence of r power n into vector r, n plus 3 r power n, and curl of r power n into vector r is 0. So let me now take the first problem, that is a gradient of 1 by r square. So as all of you know, whenever f of r is there, so you can use this result, gradient of f of r is f dash of r by r into vector r. So where your f of r is nothing but 1 by r square. So differentiate that once. It gives minus 2 by r cube. Substitute here minus 2 by r cube by r. That is minus 2 by r power 4 into vector r as expected we got. Now similarly we take the second problem where we need gradient, sorry, it is divergence of r by r square. So it is a scalar multiple of vector. So 1 by r square is scalar and r is a vector. So I can make use of identity divergence of phi times f, which is nothing but grade phi dot f plus phi times div f, where phi is r 1 by r square and vector r, that is nothing but vector f. So I substitute divergence of 1 by r square into vector r is nothing but gradient of 1 by r square dot vector r plus 1 by r square times div of r, where div of r is nothing but 3. So this gives 3 by r square. Now gradient of 1 by r square, which we already got here, it is minus 2 by r power 4 into vector r. I substitute over here, that is minus 2 by r power 4 into vector r dot r, where r dot r is nothing but r square. So r square into minus 2 by r power 4. So r square and here r power 4 gets cancelled, leaves r square minus 2 by r square plus 3 by r square, which is nothing but 3 minus 2, 1 by r square, that is the expected one. So the divergence of r by r square is 1 by r square by using the identity we got. Similarly, now if I want divergence of r power n into vector r, so how I can get? That is, I need to prove that divergence of r power n into vector r is n plus 3 r power n. So I can use the same result once again, the identity divergence of phi f equal to grade phi dot f plus phi times div f. So here phi is r power n and f is vector r. So that is a gradient of r power n dot vector r plus r power n times divergence of r, which is nothing but 3. This gives 3 r power n. And gradient of r power n is, if I know, I can write directly n r power n minus 2 into vector r, or I can use the result again, del of f of r is f dash of r by r, where f of r is r power n means n r power n minus 1 by r is nothing but n r power n minus 2 into vector r dot r dot r is r square into r power n minus 2 gives r power n. So n r power n plus 3 r power n, which is nothing but n plus 3 r power n. The fourth one, I need again curl of scalar multiple of vector r. So I can use the identity on curl, that is curl of phi f equal to grade phi cross f plus phi times curl f, where phi is r power n and f is vector r. So del cross r power n into vector r means del of r power n cross r plus r power n into del cross r. Now student, del cross r, curl of r is 0. So this gives 0. Now here del of r power n is n r power n minus 2 into vector r cross r. But this already I have r cross r, that is 0, since because of that. So I can substitute here, this is also 0. So 0 plus 0. So answer is 0. So as expected. So divergence of r power n into r is n plus 3 r power n and curl of r power n into r is 0. Question number 7. If f equal to r power n into vector r, then find for what value of n the vector field f is solenoidal, irrotational, both solenoidal and irrotational. This problem we have just taken in the last slide, where we got divergence and curl of r power n into r. Now solenoidal vector means divergence should be equal to 0. Irrotational, that is curl, should be equal to 0. So again let me take the divergence of r power n into r just by using that identity divergence of phi f, which is nothing but grade of r power n dot vector r plus r power n into divergence of r, where divergence of r is 3. I substitute that 3 r power n and grade of r power n is n r power n minus 2 into r. So r dot r is r square. After simplifying we'll get n r power n plus 3 r power n, which is nothing but n plus 3 r power n. Just now we have taken. Now similarly irrotational, so curl of r power n into r by using the identity, that is del cross r power n into r scalar multiple of vector, which is nothing but grade of r power n cross r plus r power n into curl of r, where curl of r is 0 and grade of r power n is n r power n minus 2 into vector r cross r, but r cross r is 0, so we'll get 0. After getting this, now I can go for answering one by one. Solenoidal. R power n into R is solenoidal means what? Del dot R power n into R should be equal to 0, which is nothing but the grade is already we got, sorry, divergence we already got, that is n plus 3 times R power n. Equate that to 0 means n plus 3 equal to 0 or n equal to minus 3. So for n equal to minus 3, this becomes solenoidal. Now for what value of that n, the vector becomes irrotational. Already you got curl of R power n into vector r is 0, correct? So that means for all values of n, r power n into r curl is 0. So that means for irrotational, irrespective of n, the r power n into vector r is 0. So for all values of n it is 0. Now I want to find for what value of n it becomes both solenoidal and irrotational, means intersection, that is n equal to minus 3, because for n equal to minus 3 anyhow it is solenoidal, and for n equal to minus 3 it is irrotational also. So I can take, hence when n equal to minus 3, the vector r power n into r is both solenoidal and irrotational. So student, the question number 8, prove that 1 by r cube into r is both solenoidal and irrotational. So just now we have taken r power n into vector r. So for what value of n, this becomes solenoidal, irrotational, both solenoidal and irrotational. So for both solenoidal and irrotational, when n equal to minus 3 we got. If I substitute n equal to minus 3, r power minus 3 means 1 by r cube. So the same problem. So sometimes they can ask this way also. Then if you want, you can first get divergence of r power n into r, not a problem. Get that result and you can get that number n equal to minus 3. But instead of that, you can straight away take this problem by applying again the same divergence of phi f, that is here phi is 1 by r cube and r is, f is vector r. So divergence of 1 by r cube into vector r is nothing but grade of 1 by r cube dot r plus 1 by r cube into divergence of r. Divergence of r is 3 by r cube, and gradient of 1 by r cube, you can use the same result del of f of r, f dash of r. F dash of r is here derivative of 1 by r cube, differentiate that. So that is minus 3 by r power 4 divided by r minus 3 by r power 5. R dot r is r square. R square by r power 5 means minus 3 by r cube plus 3 by r cube. As expected, the answer is 0. Now curl of that 1 by r cube into r, again you can use the same identity, that is curl of phi f, which we have already taken, that is grade phi cross f plus phi times curl f. Use that. So del cross 1 by r cube into r, that is the gradient of 1 by r cube cross r plus 1 by r cube into del cross r. Curl r is 0. And this already you got minus 3 by r power 5 minus 3 by r power 5 into vector r, but cross r, but r cross r is 0, so that's why it is 0. So the curl of r by r cube is 0, means it is irrotational. Now take question number 9, which is now given if f equal to x square plus y square plus z square power minus n, then find divergence of grade f and determine n if divergence of grade f equal to 0. Now div of grade f means del dot del f, del square f. But if you see, this is nothing but r square, correct? So that means f is a function of r. Whenever f is a function of r, we can use del square of f of r, that is f double dash of r plus 2 by r f dash of r. So I take f equal to, that is r square power minus n means r power minus 2n. So differentiate twice f dash of r, that gives minus 2n into r power minus 2n minus 1. Again differentiate f double dash of r, that is minus 2n into derivative of r power minus 2n minus 1 is minus 2n minus 1 into r power minus 2n minus 2. But minus of 2n plus 1, and outside I have minus here, minus of minus plus. So 2n into 2n plus 1 r power minus 2n minus 2. Directly substitute over here. That gives the answer of divergence of grade f, that is f double dash of r 2n into 2n plus 1 r power minus 2n minus 2 plus 2 by r times f dash of r, that is minus 2n r power minus 2n minus 1, which now simplifies to r power minus 2n minus 1 divided by r is r power minus 2n minus 2. So I can take the common term, that is 2n into r power minus 2n minus 2 taken out. So remains 2n plus 1, and here it is minus 2 plus into minus 2. But 2n plus 1 minus 2 is 2n minus 1. So I have the final answer, divergence of grade f, where f equal to x square plus y square plus z square power minus n is 2n into 2n minus 1 r power minus 2 times n minus 1. Now, how I can answer this? When it becomes 0, what is the value of n? So I can equate this to 0. So divergence of grade f equal to 0 means 2n into 2n minus 1 into r power minus 2n minus 1 is 0. So that means 2n minus 1 equal to 0. So if I take 2n equal to 0, n becomes 0. So which is common because it becomes constant, power 0, the constant. So for constant anyhow it is 0. So I have 2n minus 1 equal to 0 means n equal to half. So I require the n value is half so that the divergence of grade f becomes 0. So the last question we are taking here, the number 10, if vector v is equal to cross product of vector omega and r, where vector omega is omega 1i plus omega 2j plus omega 3k and r is xi plus yj plus zk, then prove that curl of v is equal to 2 times omega, vector omega. So this actually, while taking the interpretation of curl, we have taken that if v is the velocity of a particle in a rigid body rotating about a fixed axis with uniform angular velocity omega, then curl of that velocity is twice the angular velocity. Now I can prove that. So I have to find curl of v. But what is v? That also we have to first obtain, that is the cross product. So v is equal to omega cross r. So find this, first expand this. So what is that? Determinant of ijk, the component of omega is omega 1, omega 2, omega 3 and r is x, y, z. So I take the determinant, expand along the first row, plus minus plus I into omega 2z minus omega 3y minus j into omega 1z minus omega 3x plus k into omega 1y minus omega 2x. So this is your vector v. Now curl of v means del cross v. So del cross v, that is determinant ijk, del component dou by dou x, dou by dou y, dou by dou z. The component of v is here omega 2z minus omega 3y. Then component of j is not just this, minus of, so I have minus of minus plus, so omega 3x minus omega 1z, and component of k I have written here omega 1y minus omega 2x. So determinant we can find I into dou by dou y of this partially differentiate with respect to y means treating x constant, so I have omega 1 minus dou by dou z of this means minus omega 1 minus of minus plus the component of I is 2 omega 1 minus j into dou by dou x of minus omega 2 minus dou by dou z of omega 2, that is minus omega 2. So I have minus of minus plus, outside I have minus, so minus of minus plus 2 omega 2j, and similarly component of k is dou by dou x of, that is omega 3 minus dou by dou y of minus omega 3 minus of minus plus omega 3 plus omega 3, 2 times omega 3. So I have 2 times omega 1i plus omega 2j plus omega 3k, that is equal to 2 times, this is nothing but omega, vector omega. So I got curl of v, where v is the cross product of angular velocity and the position vector, then curl of v is 2 times the uniform angular velocity. So I have taken all the concepts of vector differentiation in these 3 video lecture series. So you can look forward for vector integration in coming series. Thank you.